Hi, I'm Randall Heyman, a university academic. You're on one of my Corona Help playlists where I do quick turnaround videos to help students and educators during the coronavirus outbreak. If you'd like me to make a video for you or your students, then just comment below any of my videos, or if you like, you can drop me an email. Okay, so let's work through the problem I have today. It is for, let me get my black pen going. Let's go to black pen. Saksham, who emailed me. Amazingly, he says he's only 13 and he's looking at Fourier series, which is quite an advanced concept. He said he enjoyed my video. I've got a video, Fourier series made easy. It's a really good introduction to Fourier series, so that's a good start if you're interested in this subject before you dive into the textbooks. Now, in it, I explained that often examiners will give you, will make it easy for you by making the period of this function 2 pi. It makes all the numbers easier. So the idea is that we've got some sort of graph. It might be a step function even, something like that. Sort of this shortest shape. And I was saying that it repeats, this is the period here, from here, when it starts to go up to when it goes up. So I was saying that that was 2 pi, special case. You don't need it, we just need it to be periodic, but as I said, often it's 2 pi. So how does this work? Well, if it's not 2 pi, then you can't use the formulas that I had, or you have to change slightly the formulas I had in my video. So let's just go through it. So we have an, the an terms, use 1 on L, between negative L and L, fx. This is the function up here, fx, that we're trying to work out the Fourier series for, times the cosine of n pi x on L. And that would be dx. And this is for where, so this is now considering the case where fx is periodic with period 2L. Okay, so that's an. You'll also need the bn terms, and a similar sort of idea, if Saksham's watching this, instead of 1 on pi, we have 1 on L, negative L fx, and of course it'll be sine x. Well, it's not sine x, it's sine n pi x on L dx. And I hope you can see that the major saving when you're an examiner in terms of not causing your students grief on exam or test questions is that you want to make these cos and sine terms as easy as possible. So by making pi equals L, then this all just cancels down to, in this case here, it'll just be cos nx, and in this case here, it'll just be sine x. So that's where it really makes it a lot easier. Okay, let's go to black, and we'll just do the final one, which is A0. And depending on what your formula is for the Fourier series, if it starts with A0, then you're going to use this formula. If it's A0 on 2, then you're just going to have 1 on L. Okay, negative L to L fx dx. Really beautiful idea, Fourier series, and for those of you that would like to just sort of get a bit of a glimpse of it without doing all the hard maths, you might have a look at my other video, how JPEG works, which is that image compression tool works. There I go into, you can see the sort of idea of layering on or summing up all these cosine functions and sine functions. It gives you a very good approximation to the curve fx or whatever you decide to call it in your situation. Okay, so I hope that's helped, Saksham. If you've got any more questions, Saksham, by all means, get back to me. And for anyone else, for any aspect of mathematics, if I think I can help you, I will. So just drop me a email or comment below any of my videos and I'll try and help you out.